Welcome to our new lesson, Pure Substance and Mixtures. Let's start by warming up and what is the definition of pure substance? Pure substance is a substance that consists only of one type of molecules and has specific physical and chemical properties. According to the type of molecule, we may have elements or compounds. Molecules of elements consist only of one type of atom, like hydrogen molecule. Hydrogen gas consists of several number of hydrogen molecules. Each one of hydrogen molecules consists of two hydrogen atoms. Now, the second type, which is compound. So, in compound, the molecule of a compound consists of two or more different atoms, like the molecule of water, as example, consists of one oxygen atom and two hydrogen atoms. So water consists of water molecules which are identical to each other, and each molecule consists of different type of atoms which are oxygen and hydrogen. Now that's about pure substance, which are elements and compounds. Now, what about mixtures? And before talking about mixtures, we will talk about the effect of physical change on pure substance. Physical change has no effect on pure substance. What about mixtures? Mixtures are combination of two or more pure substances that are combined physically but not chemically. An easy example is pizza. Pizza consists of many ingredients which we can see by our eyes. We can increase some components and decrease another components. Another example we have is salad. Now, how can we separate a mixture using physical change? First, we can use a tool like magnet. Magnet works by magnetic attraction, so we can separate a mixture of iron nails and aluminium nails by using magnet. Of course, only the iron nail will attract to the magnet. Another example of centrifugation. How can we separate a mixture of blood sample? By using centrifugation. In centrifugation, the samples of blood are rotated very fast, so each sample is separated into components according to the density of the components. So by centrifugation, we can separate mixtures by their density. So here we see the blood sample and we see also the components of the blood sample. Another tool is using sieve. According to the whole size of the sieve, mixtures can be separated by the particle size. Only the holes will determine which particle will go through the holes and which particle will stay on the sieve. Another example is heating. By heating, we can evaporate liquids and only solids remains in the glass flask. So if I have a salty solution and I wanted to have the salt, I should heat the solution until all the water evaporates, then I will find the salt there. Another way is filtration. Filtration using filter paper is an important way to separate mixtures of solutions and undissolved salts or undissolved particles. Simply, undissolved particles are stay on the filter paper. Now, how can we classify mixtures? We can classify mixtures by using their kind of distribution throughout the mixture. Now, if we have a mixture that has a uniform composition, or the molecules of the mixture is equally or uniformly distributed throughout the mixture, so we have homogeneous mixture. Homogeneous mixture simply is like solution. Solutions are a homogeneous mixture in which all particles are equally distributed throughout the whole amount of mixture. We have liquids, we have gaseous solutions like air, and also solid solutions like steam. Now, if molecules don't distribute evenly throughout the mixture, we will have heterogeneous mixture. We have two examples of, or two types of heterogeneous mixtures, which are suspensions and colloids. In suspensions, the particle size will settle down, will cause the particles to settle down, and if we don't shake the mixture, continuous shaking, or every few minutes, it will settle down. What about colloids? The difference between colloids and suspension is the particle size. In colloids, particle size are small enough to keep suspended in the solution and never, or keep suspended in the colloid and never settle down. So that's the difference between colloid and suspension.